Hello, today we're going to explore a fascinating and useful topic in mathematics, divisibility tests. By the end of this video, you will be able to understand what divisibility tests are, apply a specific test for the number 13, and use a shortcut to find decimal answers for division problems involving 13. So what exactly are divisibility tests? They are simple rules that allow us to quickly determine if one number can be divided by another number without leaving a remainder. In other words, they help us check if a number is a factor of another number, or if a division problem will result in a whole number. Why are these tests useful? Well, they can save you a lot of time. Instead of performing long division, you can use a quick mental check. This is especially helpful for simplifying fractions, finding prime factors, or just getting a better feel for numbers. They are a powerful tool for mental math and number sense. Now, let's dive into our first specific test. We're going to learn the divisibility test for the number 13. This test might seem a little unusual at first, but it's quite clever. Here's the rule. To check if a number is divisible by 13, you take the last digit, multiply it by 4, and then add that result to the rest of the number. If the new number you get is divisible by 13, then the original number was also divisible by 13. Let's write that down. The rule is, take the last digit, multiply it by 4, and add it to the remaining digits. You can repeat this process as many times as you need until you get a number that you can easily tell is or isn't a multiple of 13. Let's try an example. Is the number 325 divisible by 13? We'll test 325. First, we identify the last digit, which is 5. The last digit is 5. Next, we multiply that last digit by 4. So 5 times 4 equals 20. 5 times 4 is 20. Now we take the rest of the number, which is 32, and add our result 20 to it. 32 plus 20 equals 52. We are left with the number 52. Is 52 divisible by 13? Yes, it is. 13 times 4 is 52. Since 52 is divisible by 13, our original number, 325, must also be divisible by 13. Let's confirm with long division. 325 divided by 13 is indeed 25. The test works perfectly. Now, what if a number is not divisible by 13? We can use a clever shortcut to find the decimal answer without doing long division. This shortcut is based on a fascinating property of the number 13. The key is to remember that 1 divided by 13 is a repeating decimal, 0.076923, and this block of 6 digits repeats forever. So 1 divided by 13 is 0.076923, repeating. To find the decimal for any number divided by 13, you just multiply that number by this repeating block. Let's see how it works with an example. Let's find the decimal for 72 divided by 13. First, we find the whole number part. 13 goes into 72 5 times, because 13 times 5 is 65. So the whole number part is 5. The remainder is 7. This means we need to find the decimal for 7 divided by 13. We need to calculate 7 times our repeating block, 0.076923. Let's multiply 7 by 76,923. 7 times 76,923 is 538,461. The result is 538,461. Now we place this after the decimal point. So 7 divided by 13 is 0.538461, repeating. Combining the whole number and the decimal, we get our final answer. 72 divided by 13 is 5.538461, repeating. Let's try another example to solidify this shortcut. Let's find the decimal for 693 divided by 13. We'll work through this one step by step. First, the whole number part. 13 goes into 693 53 times. 13 times 53 is 689. So the whole number part is 53. The remainder is 4. This means we need to find the decimal 44 divided by 13. We'll multiply 4 by our repeating block, 0.076923. Multiplying 4 by 76,923 gives us 307,692. The result is 307,692. So 4 divided by 13 is 0.307692, repeating. Combining the whole number and the decimal, we get 53.307692, repeating. Let's do one more, a larger number. 5,481 divided by 13. This will show how the shortcut works for bigger numbers. 13 goes into 5,481 421 times. 13 times 421 is 5,473. The whole number part is 421. The remainder is 8. We need the decimal for 8 divided by 13. We multiply 8 by our repeating block. 8 times 76,923 is 615,384. The result is 615,384. So 8 divided by 13 is 0.615384, repeating. Our final answer is 421.615384, repeating. Now let's apply these skills to a real-world problem. Here's a homework question. The moon goes around the Earth approximately 13 times a year. How many years would have passed when the moon has orbited the Earth 317 times? To solve this, we need to divide the total number of orbits, 317, by the number of orbits per year, which is 13. So we need to calculate 317 divided by 13. First, let's use our divisibility test for 13 to see if the answer is a whole number. This will tell us if the moon completes a full number of years. We'll test 317. The last digit is 7. We multiply it by 4. 7 times 4 is 28. 7 times 4 is 28. Now, we add this to the rest of the number, 31. 31 plus 28 is 59. 31 plus 28 is 59. Is 59 divisible by 13? No, it's not. 13 times 4 is 52, and 13 times 5 is 65. So, 317 is not divisible by 13. This means our answer will not be a whole number of years. Since it's not a whole number, we'll use our shortcut to find the decimal answer. First, the whole number part. 13 goes into 317 24 times. 13 times 24 is 312. The whole number part is 24. The remainder is 5. We need the decimal for 5 divided by 13. We multiply 5 by our repeating block, 0.076923. 5 times 76,923 is 384,615. The result is 384,615. So, 5 divided by 13 is 0.38461, repeating. Combining the whole number and the decimal, we get 24.384615, repeating. So the answer to the homework problem is that approximately 24.38 years would have passed. We've seen how useful divisibility tests can be. But what about larger numbers? Let's briefly discuss divisibility tests for higher numbers. For composite numbers, like 15, 16, or 18, the tests are often a combination of simpler tests. For example, to check if a number is divisible by 15, you just need to check if it's divisible by both 3 and 5. If it passes both tests, it's divisible by 15. For prime numbers like 17 or 19, the test can get quite complicated. They often involve multiplying the last digit by a larger number and adding or subtracting it from the rest of the number, similar to our test for 13. For instance, the test for 17 involves multiplying the last digit by 5 and subtracting it. The test for 19 involves multiplying the last digit by 2 and adding it. While these tests exist, they are often not as quick or practical as the test for smaller numbers. For larger numbers, especially in a real-world scenario, it's usually faster and more reliable to just perform long division or use a calculator. The complexity of the test can outweigh the benefit of avoiding long division. So to recap, we've learned what divisibility tests are, how to apply a specific test for 13, and a clever shortcut for finding decimal answers. We also saw how these tools can be used to solve a practical problem. I hope this has given you a new appreciation for the patterns and shortcuts hidden within numbers. Thank you for watching.